Did Google's Willow chip just leverage the multiverse to compute a septillion times faster than the best classical computer, enabling it to crack all encryption and achieve superintelligence? I'm Dan Burke, and welcome to Abstract Codex. So did Google's Willow chip crack the multiverse? No. But wait! I just read this from Google's official blog. Willow's performance on this benchmark is astonishing. It performed a computation in under 5 minutes that would take one of today's fastest supercomputers 10 to the 25 or 10 septillion years. This mind-boggling number exceeds known timescales in physics and vastly exceeds the age of the universe. It lends credence to the notion that quantum computation occurs in many parallel universes, in line with the idea that we live in a multiverse, a prediction first made by David Deutsch. Alright, well, first let's look at this computation that Willow performed.
First, they can solve the most complex problem that we have ever tried to solve. I don't even know what it is. I'd like to ask that question.
Sure, Glenn, happy to help. It isn't the hardest problem, or even a real problem. It's a benchmark called random circuit sampling, or RCS. RCS isn't a useful computation, and should probably not even be referred to as a computation. It is essentially producing a set of numbers that match the probability distribution of a randomized quantum circuit. But rather than take my word for it, let's listen to Google Willow lead Hartmut Nevin.
Random circuit sampling is not useful for an application.
So why isn't RCS useful? Because it is just reporting its own state. It is slow for classical computers to produce similar output, as they would need to simulate the innate behavior of the qubit interactions. The quantum computer performing RCS isn't simulating something else, it is just reporting its own state. It's like saying an apple fruit has achieved computational supremacy because it can instantly display a super detailed texture on its surface, down to the molecular level, that would take a lot of computational power to simulate. Self-reporting is not a computation. What about this oft-repeated claim based on Google's blog?
They're pulling answers from different universes simultaneously.
To explain this claim, I'll need to take you on a journey into quantum mechanics. But don't worry, we'll do more of a high-altitude flyover. Quantum computers work by manipulating facets of quantum mechanics. They have a matrix of qubits that are maintained in a state of superposition. These qubits are entangled with each other to form the equivalent of logical gates. Clever scientists manipulate the interference pattern that is produced, while the qubits are still in a state of superposition, in order to achieve the desired outputs.
What I don't get, how does that provide evidence that the multiverse is real?
Let's look at a more simple and very popular quantum mechanical experiment you may have heard of, the double-slit experiment. I'll refer to photons in the experiment, but electrons or other objects can be used. In this experiment, we fire a photon one at a time into a sheet with 2 slits. We have a detector screen on the wall behind the device. The photons produce an interference pattern on the wall consistent with what a wave would produce, even when the photons are fired one at a time. But if we repeat the experiment and place a detector on one of the slits to see which one it went through, then the interference pattern is not created, and instead we see a pattern consistent with the photon acting as a particle and just firing through one slit. This is a very mysterious phenomenon, and there are multiple competing explanations on what is going on. These explanations are referred to as different interpretations of quantum mechanics. One of these interpretations is what the Google blog post alluded to, the many worlds interpretation of quantum mechanics by David Deutsch, which, if true, can be used to hint at a multiverse, like in the Marvel movies. This interpretation suggests that we see an interference pattern even for a single photon, because when the photon reached the sheet, the universe branched into two universes, one in which the photon went through the left slit, and another in which the photon went through the right slit. These photons from parallel universes interfered with each other, and that created the interference pattern. While David Dutch is a very smart and accomplished scientist, this interpretation has multiple problems, including violating Bell's theorem. Sabine's channel, linked to below, has a superb in-depth videos to explain this. Also, the many worlds interpretation violates the rules of the law of conservation of mass energy. Every resolved superposition, which would occur billions of times every microsecond for every person, would result in an entire new replica universes being produced. Where would the energy for these new universes come from? In my opinion, and in the opinion of many physicists, there are far better interpretations of quantum mechanics, including the commonly taught Copenhagen interpretation. This states that objects in a state of superposition aren't in multiple states at once, but rather in a special state. Once the photon is observed, its wave function collapses into a discrete or normal state. This is compatible with the fascinating quantum eraser experiment, which is like the double slit but has two stages. It turns out that as soon as we use a detector to detect the position of the photon on the second stage, its superposition is resolved for the earlier state as well. Michael Jones of the Inspiring Philosophy channel, linked to in the description, has excellent videos on this topic as well as great videos on quantum computers. One part of his video shows a great clip from physicist Michio Kaku, who explains a ramification of the Copenhagen theory on the Schrodinger's cat experiment.
Eugene Wigner believed it could teach us something else about the working of the universe, that consciousness controls everything.
Wigner said, let's take it one step farther. If I, a human being, looks at the cat, I am conscious. Therefore, consciousness determines existence. At that point, Einstein went ballistic and said, what? You're saying that the fact that you are a conscious being determines the fact that the cat is alive? Answer is yes. And Wigner made one more step, and that is, how do I know I'm alive? You see, the cat and me, we're part of the same universe. If I don't know the cat is alive or dead, I could also be dead at the same time and not even know it. So who determines that I'm alive? Well, Wigner's friend looks at me, I look at the cat, and we exist. But then who looks at Wigner's friend? And there's an infinite chain of people looking at people, until finally you hit cosmic consciousness. Some consciousness that's ethereal, that envelops the universe, which looks at us and says, aha, the cat is alive.
To summarize, the act of observing a photon or anything else resolves its superpositions into normal reality. However, if you and the photon are isolated together, that can be considered a closed system. And so the whole system, including you, are in a state of superposition until you do something that causes an observable effect to another conscious observer. However, we can't have an infinite regress of conscious observers, so there must be an ultimate cosmic observer whose existence is not contingent on observation in order to cement reality, which points to the existence of God. Now, to be clear, not all physicists who subscribe to the Copenhagen interpretation believe it is a conscious observer that resolves a superposition. Some like to regard it as a mystery. Now, getting back to Joe Rogan's question, the answer is that the existence of a quantum computing device does not provide any more evidence for a multiverse than the double-slit experiment, which itself does not seem to point in that direction. Also, the parallelization of a quantum computer comes from the interference pattern of its superpositions and the entanglement relationships of the qubits, and doesn't need an explanation of coming from multiple computers in different universes. I think this idea is probably just popular as it's sometimes a fun sci-fi trope. So, is quantum computing all hype? Let's look at another quote from the Google Willow blog. Today in Nature, we publish results showing that the more qubits we use in Willow, the more we reduce errors, and the more quantum the system becomes. Yeah, more quantum? I'm not sure what the blog post writer meant by that, and I'm pretty sure that he doesn't know either. However, if we look at the rest of the statement, one of the big challenges in quantum computing is preventing the noise from increasing the error rate as we scale out and increase the number of qubits. Google claims to have solved this issue, and that would be a tremendous achievement. I don't want to sound like I'm scoffing at quantum computing. It's a very difficult field with extremely hard challenges. While RCS doesn't do anything useful, there are theoretical quantum algorithms that do indeed solve real problems. For example, Grover's algorithm can be used to reduce the complexity of a search for value in a list. And Shor's algorithm can potentially quickly factor large numbers that are the products of primes, which is a key in popular encryption algorithms. However, quantum computing is still in its infancy. We don't know when or if the challenges will be overcome in scaling these algorithms to solve problems we can't feasibly do with classical computers. Last I checked, the largest number Shor's factoring algorithm has solved in an actual quantum computing device was 35. And that was after multiple incorrect runs. So we would need a large number to be factored in order to be sure that it's really working. Quantum computers will probably never be a replacement for classical computers, as they only have the potential to provide massive gains for particular types of problems. This includes the simulation of quantum effects that occur in molecular interactions, which would be great for medical research. It is a fascinating field if you're interested in quantum mechanics, circuit design, mathematics, and algorithms. While there is a lot of hype, the field has some great research and lots of room to grow. If you are interested in this topic, I hope this can be a jumping off point to watching more in-depth videos and reading technical papers. I've provided links to my favorite resources in the description. Thanks for watching. If you found this video helpful, or even if you didn't, feel free to like and subscribe to the channel. Also, you can visit my website to sign up for my mailing list, to be notified of new content, and to check out my fantasy book series, Heroes of Teraya, also linked in the description. It will be released in 2025, so it may already be out by the time you watch this video, but you can sign up for the Heroes of Teraya mailing list to be notified of new books. Feel free to comment and let me know if there are any computer science, AI, or writing topics you would like me to cover. Thanks.